Okay, all right. Welcome everyone to this second webinar in our WebMDS sequence. So this is an event that's hosted by the SciAg on Mathematics of Data Science that I'm chairing together with my other officers, Dirk Lawrence from Bremen, Rebecca Morrison from Boulder, and Jamie Haddock. And today we have a title, we have a panel titled Career Opportunities for Applied and Computational Mathematicians in Data Science and AI, which I'm really happy to have a few great panelists here from very different walks of life at very different career stages. And we are hoping to have put together a nice program to answer career questions. And maybe just to frame it, I think right now is a very exciting moment because data science roles are projected to keep growing. I mean, there's no shortage of job postings, I think, in this area. And there are actually many nice mathematical questions in the area too. In that regard, I think it can be good to give some guidance and share experiences of what are possible career paths in that area, what does it take to succeed, and how to navigate all of these options that can consist of academic jobs, national labs, industry, and especially maybe also to highlight some of the roles where mathematician doesn't really appear in the job title, but you can still be a mathematician and benefit from this experience. I'm going to moderate this. Other people from the SciAg officers, they will probably monitor the chat, hold us to time, and kind of bring in new questions. If you have any, drop them. If you are not a SciAg member by any chance, feel free to sign up. We have Moss here and other people can tell you probably how to do that, but definitely when you renew your membership, consider becoming a part of this. And then, yeah, so I basically broke it down into 3 modules that we'll go through. I think we'll talk about career transition first, because all of our panelists have sort of at some point become a data scientist and also switched jobs and even different sectors. Then we'll talk a bit skills and education and skill development in this area, which is quite nascent and going to be shaped pretty much by some of the panelists here. And then we'll finish off with the most important thing, which is strategic career advice. What do people have to say about that? Just very shortly for me to give like a 1-sentence introduction to the panelists. You're going to see them or hear them later. We have, is Marta here? I have everyone on my screen. Of course, yes. Cool. Marta. So Marta Delia, she started with modeling and optimal control of cardiovascular flow. And she's now, and then she has held roles in academia, national labs, and now actually in industry, and has many transitions and is now director at Atomic Machines, which she will tell us all about, and has done a really nice transition here. Then we have Elizabeth Newman. Liz kind of had a steep career in academia, has done a PhD in Tufts, postdoc at Emory, faculty of Emory, now faculty position in Tufts back, and has many success stories to share also on the funding side, where she was able to build quite a strong research portfolio very quickly. And she's going to give a very early career perspective to this and hopefully some advice also, having recently applied for jobs, how to navigate that environment. Then we have David Uminsky from Chicago, and he has actually built one of the nation's first undergraduate data science programs, both at USF and now in Chicago, where he's leading the Data Science Institute. And by that, he has really shaped the educational landscape with an eye close toward inclusivity, ethics, and societal impact, which he'll speak upon. Then we have Lior Horesh. He is at IBM Research, and he has contributed to many AI and machine learning developments, and also a background in computational math much more broadly. And he can give us a good pulse on what's going on in the industry, having been there for many, many years. And finally, last but not least, we have Kevin Carlberg. Kevin has also a very rich career, having been in national labs, in academia and University of Washington, and in companies, where I think you are at right now, but he'll fill us in on that. So he can probably also chime in on a lot of aspects when it comes to career transitions in this area. Okay, so then without further ado, how about we kick it off? and talk a little bit about career transitions. And my first question I wanted to pose to Marta is, given your journey, having worked in your PhD on optimal control for computational fluid dynamics, and now becoming a director of AI at Atomic Machines, with stops at Sandia, Meta, and other labs. Can you walk us through maybe what are your key decision points in these transitions? What made you want to explore new topics, and what made you transition from academia to national labs and national labs to tech companies?
Sure, absolutely. Good morning, everybody. Thank you, Lars, for having me. Thank you for the introduction. It's great to be here. So yeah, I think I've seen it all. So this question is very appropriate for me. I started in academia, but I think I should also mention my bachelor and master's degree, which was in mathematical engineering, and in particular on scientific computing. And that's where I learned that math can actually model things and allows you to simulate things. And in mathematical engineering, they tell you can simulate anything. And so that's the direction I was going towards. That's why I picked my PhD. It felt like mathematics for good. Our collaboration was specifically with the Children's Hospital, and so you really think you can make an impact. I have to say the cardiovascular community is a small community, and so when I finished my PhD, I wanted to try new things. And that's why I did my postdoc at FSU on a completely different topic, so still control and optimization, but it was more applied to mechanics, fracture mechanics. So my objective was really to expand the field of research. And I soon realized that I wasn't in love with teaching. And so the lab looked like, a perfect place. And the point is, at least in my opinion, is that if you stay in academia and you teach students, you really should have a passion for teaching, because that's what students deserve. And so I decided that wasn't my path. At Sandia, I explored even more applications, and that felt really good, because it was really the realization of what I studied for. Like, again, you can simulate anything, and that's what I was doing at Sandia. I had to say, though, that I didn't feel like I was having a real impact, a concrete impact. But as I was at Sandia, towards the end, there was the explosion of machine learning and machine learning for physics. And it was clear that machine learning could impact society. And I have to say, when I decided to transition to industry to see whether I could really be impactful concretely. And it was truly an eye-opening experience. Like, we were building things. And it's a very personal thing, right? It depends on what you like and what you qualify as impact. And for me, the art of making things, that's what it was. And that's why I decided to stick to industry. And my current place, I think, makes a lot of sense. Atomic Machines is building a micro manufacturing platform that is AI native and fully digital. And so this is truly where, you can use math to make things. So it was, the perfect landing for me.
That's very interesting, Marta. And I have a follow-up on that, actually. So as you made these transitions, did you ever feel like there were, the expectations changing? I mean, you've published in mathematical journals initially, then you worked on applications, then you worked on industry. So like, how were these transitions in terms of just measures of success, or also the mode of how you worked and how you work with others?
Yeah, so I've been in these panels before, and this question always comes up, like, what's the definition of success? And I think success is what makes you happy. It's what makes you feel accomplished. And of course, the definition changes depending on where you work and depending on how you grow up professionally. Sometimes the definition of success is also affected by your workplace. At the lab, you're judged based on how many papers you publish, at least in my departments, and you're judged based on how much money you can raise, how much funding you can raise. Raising money gives you a lot of freedom because you can pick what to work on, and that certainly feels like success. Research is not imposed on you, but you can pick what you can work on. But it turned out that's not what I love doing. As I said before, when I moved to industry, I realized that what I loved was to make things. And in my first job, we were basically going from design, like basic PDE constrained optimization, shape optimization, to 3D printing a component of a wearable device, and we could hold it in our hands. And that's what made me incredibly happy, much happier than having published in, as you mentioned, some journals. And the thing is, I have to say, I still have a passion for math, for the elegance of math, for the sophistication of math. And in my first job, I didn't have that. But where I am right now, we can really combine like new research and making things, and that's what, in my opinion, can be defined success for me. Once again, it's I think success is should be a very personal thing.
Yeah, definitely agree on that. And I think it's fascinating to hear. I think before I open the floor to the other panels, I want to hear from Kevin, because sort of in some sense you had similar transitions, but maybe they were different, or maybe they were similar. So just wanted to hear kind of your perspective on that.
Yeah, definitely. I agree wholeheartedly with Marta's perspective. We actually overlapped at Meta for a period as well. So I think overall, the way I think about careers, especially when you have a background in computational or applied math, is you have a very rich tool set to apply to many different kind of problem domains. So the way I always thought about it, so I started, got my PhD, from there went to Sandia Labs, and from there went to Meta, and I was there for about 5.5 years. I'm currently on sabbatical. But basically, the way I kind of viewed each of those transition is, what are the opportunities that company and role affords? At Sandia, it was a lot of sort of fundamental research, and then you can use the tools from computational math related more to like deep analysis, and then mapping those analytical capabilities to problems in national security and figuring out how to operate across the full stack to support stochastic decision making. Then going to Meta, it was a very different beast. I was in Reality Labs there. We were trying to build a lot of technologies for wearable computers to form sort of the next computing platform, as Mark kind of envisioned. And there it was very different because it was much more blue sky in nature. And then you put on your kind of creative hat. And so you are less kind of dealing with well-posed problem statements, and you're more trying to figure out, how do we take this sort of company North Star vision, decompose that into actually tractable problem statements that make sense, that we can actually tackle, and further recursively decompose that into sub-problems that teams can then actually solve to make progress towards this sort of ambiguous North Star. So I feel like really the way I view, if you have a background in computational math, you have a very rich tool set to apply to many different industries. And I would encourage everyone to sort of chase your interest, understand like what excites you, and you don't have to stay in one lane your entire career. You can go from doing deep analysis, deep technical research, to more open kind of blue sky technology investigations, to finance. There's many different ways you can go, but I view it as sort of a big adventure. And so whatever kind of challenge excites you in the moment, bite off a chunk of time, 3, 4, 5, 10 years, and chase that down, but don't feel like you're beholden to that for the rest of your career.
Okay, great. Does any of the other panelists have anything to add on their transitions or follow-up questions? Or were there questions from the audience, Dirk?
No, nothing I noticed yet until now.
Yeah, I did have a follow-up for Kevin, actually, since we have him. So you mentioned these different ways and different hats you can wear in different labs. What about sort of the day-to-day pace of work? Did you notice any differences between the different sectors, and what are they? What should people be aware of?
Marta can also comment on this very well, I'm sure. So the way I kind of experienced it, the national labs, we were in more of like the fundamental research aspect of the national labs. And that there was much more of the academic cadence of work. You write proposals, you get funding, you build a team, you publish, and then you, of course, deliver software and other outcomes to hopefully partners that you've established over on the sort of weapons side of things. I would say the sort of like where the real work gets done there. And so there was much, I would say, slower paced, deeper work with less of a pressure cooker, but it's much more technically sophisticated. And I would say like really like, pulls at that part of your training. At Meta, it was much more frenetic. I would say the targets change much more regularly. We have, biannual performance reviews. And because I was operating in the space of AI for wearable computers, that space is obviously very dynamic. And so just the pace of progress, staying on top of everything, and the shifting priorities as the landscape shifts in industry, as well as the landscape shifts in research, it just led to much higher, that the half-life of any good idea is probably 3 months there. So it was very, very different. It had positives and negatives, I would say, but yeah, just very different experiences overall.
Yeah, great. David, you wanted to say something about
Yeah,
your
so
perspective.
full disclosure, my career looks transitionary, but from a broad view, it's staying in academia. So, I wanted to be mute here. But one of the things I have learned is I'm going to speak to actually, I think a lot of the people that are attending are correlating in the math field right now. And we've actually made intellectual and career changes on this panel. And I think the opening question speaks to something that I think I work a lot on right now, which is how do we advise graduate students, postdocs, and even undergraduates in these transitions through math. And I will say, it's actually interesting. So now, I started off as a very pure mathematician, non-commutable harmonic analysis, then moved into PDEs and analysis and dynamical systems, but I kept drifting intellectually to more applied areas on my own. And my advisors more or less sort of encouraged that. But the role in terms of jumping out of academia is something different and a bit cultural. I don't want to make sure I have our panelists on the spot about this, but my advisor is very supportive and would have put on a nice face, I think, if I said I want to leave academia and do something else. But many do not put on that nice face. I will say my academic appointment now is in computer science, which is, at U Chicago. And I will say there, culturally, advisors play a big role in helping them get jobs in industry, much bigger and much more proactively than I would say the math culture in general still is. So I want to note that, Camille, you mentioned how playing a role. I feel that your advisor's relationship best. If you think your advisor will help you, genuinely support you in this way, then I would really double down in having this conversation with advisors. If you feel like quite the opposite and don't answer now, I would say it's really important to find another mentor to help you with that transition. The role out of academia and these things have great landing points. They can be accidental or they can be thoughtful, and both can have good outcomes. But definitely, at least in the way I've hoped to help our students here in that role, and maybe folks here on this call know, actual mentorship, finding someone who's going to support that transition can help answer a ton of questions. So I am strongly supportive of identifying a mentor throughout your whole career, but in particular in a transition point.
Yeah, that's great advice. And David, since we have you, we can actually move to our skills and education development segment, because you've built data science program at 2 universities,
Yep.
not just one. And you've basically, in some sense, by just doing that, you've sort of defined what are the important skills people need to have. I'm curious, sort of how did you approach this, and also how did you sort of have a cycle where maybe you follow up with your former graduates and maybe also people in industry and see sort of what are the skills that you thought were important and they actually reported back to you were important.
I think you've just hit on, Lars, something I could spend an hour on. So you're going to just have to give me a signal when I'm going too passionate or too long. So,
yes.
When I was in a postdoc, I was at UCLA working in a great applied math group, and that was my career, and that was going to be my research focus. And then accidentally in 2009, funny talk started wandering into the math department from like researchers at Netflix. And they said, gee, we don't know how to offer movies to the right people. I think it's a math problem. And it struck me that there was a moment where math could play a magnanimous role in this field that was yet defined, called data science now and data science and AI, or basically, algorithmic and mathematical thinking in decision-making processes and research. And I right then decided that this was going to be like what I was going to focus on. I had big machinery in mathematics to apply in these areas. Turned out at that point and still today, if you bring a mathematical lens to this field, you have great breakthroughs that people have not found yet. In optimizations, dynamical systems, take your pick and attack this field. You'll find surprising wide open fields research-wise to push forward. And my selfish perspective was I thought this was a way for math to keep relevant with our current students. Like when I was growing up, I loved math for math's sake. I didn't need a motivator. If you needed a motivator, your winning motivation was coupled oscillators. Maybe you graduate to fluids, right? Those are classically perspectives on where math can make a change in the world. But if you're passionate about that, I decided right then I'm going to build education programs that are focused on that. It became data science very early on, still is probably the best descriptive field of what this is. But it has, it started off at you could look at different paradigms of data science education. Math plays a core role and to this day still does, because you need to fundamentally solve problems, right? And be a very good problem solver, logical, rigorous, hard thinking. I will tell you the worst versions of some of the applications and uses of AI and data science come from the fact that there's some missing foundations still. So our core perspective on developing education here is simultaneously giving tools to our students, the next generation, and make them deep thinking around the core of this field. And at the same time, you got to know how to solve a real world problem. So when we built education programs, particularly at UChicago, it was kind of radical for UChicago. We required an experiential learning component of this degree. You must work with a company, you must work with a nonprofit or a social impact organization or a government or a research lab, but you must attack in the framework of a data science team, a hard real world problem. And having that requirement be in there, along with another thing I really am passionate about, is making sure people understand the downstream effects of the work they're about to solve. Those two pieces have been like kind of the North Star of ensuring our students can think hard, prove theorems, write code. Those are core to the skill, but also how do you work on a team in data science? How do you communicate the results of a real world problem? How do you stare at messes that don't fit cleanly into the assumptions that you have and work your way through that? Those are some of the longevity as coding becomes easier, whether you leverage AI tools or not, where some skills I said were a major requirement, what you need to know before moving forward, are becoming a little fuzzier. That fundamental set of skills around problem solving and attacking hard, messy problems with rigorous points of view, that's still been our main focus. Yeah.
Can I ask you a follow-up on that? So since you so does that mean that, I mean, of course, the way you teach these courses differs quite a lot, and you have a quite unique design of bringing experiences there, but actually if I look at a transcript of a student, like has the selection of courses been changed? And also, has this been changed even over the last couple of years as technology advances? What are sort of the main things that one needs to have on a mathematics of data science transcript?
Yeah, I would say that we decided to do it the hard way. So for example, we launched a PhD in data science, very strong foundations, mathematical focus, along with applications. The thing we did not do was cobble courses that existed together. We grabbed faculty that are thinking about this as a new field, and we wrote from scratch what we think a student now needs to do to be at the forefront of research in this area. And just taking that perspective meant a lot of hard arguments across disciplines, mathematics being at the center, statistics, computer science, and other folks, essentially intellectually fighting over what's the most important thing and finding consensus. That also meant when we were done and admitted our first class that we knew we would iterate. So already the courses are iterating, the requirements, the electives that weren't there are changing rapidly. The field itself, particularly around AI, is something that we're focused on not missing a core foundations approach to, but also the core applications. And so the way we teach this too can still be a combination of traditional lectures, but it's very hands-on lab at times as well. With the advent and use of AI in the class, we're thinking about it in both directions. How does AI play a positive role in the educational experience? And also, how do we ensure the students learn to think like a data science in the age of AI technology around them. It's very easy to kind of mask your lack of understanding with some of these new tools. And it's just an ongoing and very hot conversation right now, at least at U Chicago, and getting that right.
Okay, great. Then, so I want to hear also from Liz, because I thought she could add a very nice faculty experience to this, because in some sense, I think she's been balancing, or all of us are balancing constantly to between this exploration exploitation dilemma, to explore new tools and new ideas versus also to keep our research and funding and paper machines going, or producing products. Liz, do you want to speak a little bit to that?
Yeah, sure. I don't know if I have too much to add to what David's doing, because he's really on
You do.
what he's doing. I'm the early career person here. But something I'll add is that I've actually selfishly tried to use students to learn about the newest fields as well as give them a research experience. So a lot of trying to get students involved in research sooner, maybe through reading courses to start, build up long-term relationships. And then maybe getting them to an honors project if they're undergraduates, or a thesis if they're master's students or PhD students. And I've been able to learn a lot from students doing that, because they come with their skills, and then I can kind of assess where they have some gaps that I can fill in. So I don't know if that really helps, but I always try to hit kind of the trifecta of rigorous mathematical thinking, coding, learning how to write and reproduce experiments, and learning how to read new research papers. So happy to elaborate, but I don't think I can do much more than David did on this particular topic.
Well, I think what you could talk a little bit on is, I mean, okay, so you said basically balancing this exploration exploitation dilemma is, I mean, you use you incorporate students into your group to explore new topics, but then at the same time, like, you also have to make sure you keep going. And sort of, how do you make a decision, sort of, if you have a new idea, like what to give to students and versus what to do on your own?
It's a good question. Usually I am, I don't have a great answer for that. I usually have I've done some initial work that I see is promising, and then have some sub projects I pass on to students, with varying levels of success in that regard. I've also had situations where students come in and they've really driven the research in a whole other direction. And I think that's been pretty exciting as well. So I guess I'm constantly looking for students who fill both of those roles, of someone who comes in and they're interested in a particular topic and we find a way to work together, and other times where I'm a student, I can really say, here's a project, I need progress in this direction. And that's both have worked, I think. So
yeah, so there is a natural transition point, hopefully, mostly. Great. Lior, you wanted to add something?
Yeah, so one thing I wanted to say is we are living in a very, very unique time as we currently see transformations in AI. And I'm sure that every student and each of us is asking themselves, what are the type of skills that they need to equip themselves in order to be competitive and even relevant in the future. So obviously, being mathematicians, we are curiosity driven, and we are creative, and we are problem solvers, and all of those, I would say, attributes are great things to have in mind. But being a little bit more concrete, right, down to what can I now start learning, at least what we see is that where those large language models are still struggling is where it comes to doing things that are more rigor, more formal. So one thing that we encourage researchers in general, not only young researchers, is to look into learning a little bit more about formal methods. It's a topic that is a little bit outside our jurisdiction, right? We are not computer scientists, and we are not as versed with Turing provers and assisted or automatic systems to do that and so forth. But we are actually all very versed in formal methods. We know how a proof looks like. We know how to the mechanics of going from a set of axioms to a proof and coming up with corollaries and lemmas and so forth. But we all do that very manually, and we feel comfortable in that conduct. It may be a good opportunity if you would like to be one step ahead of the game to equip ourselves with some skills around formal methods. I believe that at the very least it will give us a little bit of an edge compared to others. Another comment I can make about skills, and I think that coming from an industrial environment, on the one hand, you often do see that there are, or at least until now, there have been requirements to have more hands-on skills. And in many industries, you would find that even the interview to get inside requires coding something or doing something of that sort. I believe that it is changing these days, but it is still the trend. On the other hand, if you find yourself in a relatively large research group within the industry, because of the scale, you may be able to specialize more in one topic rather than another, right? So at the end of the day, as long as the collective possess the required skills, so there are software engineers that will write industrial level codes, there are maybe mathematicians that will, even pure mathematicians that will do what they do best, as long as the composite of all of them together makes a union that fulfill the requirements that are needed for a project or for some strategy, that should be okay. But it really depends on the scale of the organization that you are looking into. So just take that as another dimension, right? So it's a question as for, don't think about yourself only as an individual, but where you are in the collective of a team or a group. That team may be small or may be large. It may have narrow or broader set of skills, and fitting in is also actually being a good team player is probably one of the most required skills in the industry.
Yeah, thanks, Lior, for that point. Any of the other panelists want to chime in on this, Kevin or Marta?
I can just follow up. Oh, sorry, Kevin. If you want to go, please go ahead.
I think you have the floor now, Marta.
Oh, okay. Sorry. No, I couldn't agree more with Lior. And I think what he was implying in a way is the need for cross-functionality in industry. It's true, we come with all sorts of backgrounds and skills, and being able to communicate with each other and find that common language is fundamental. And that's the true teamwork, the ability to understand each other and work well together. But also being willing to learn and continuously learn and deeply understand the problems that we're working with. And I think this is one of the fundamental differences between industry and academia, but also the labs in a way. I always felt like in academia is you as an individual, while in industry, it's really like a team effort. And for that reason, it's so important to be able to work with others. And what I realized when I moved to industry is the ability to code with others. And it's something that in academia, you don't really practice, but it's something that I strongly encourage. Like for all the professors here, push your students to code in a team, to share their codes with others. Otherwise, they're gonna hit the industry world and realize that other people might not be able to use their codes. And that's just not working. So I just wanted to add this.
Oh, that's actually a great point. I think you hit the nail on the head on that front. Great. So I would want to move on then a little bit more to the practical side on like career advice. And this Kevin. Oh, sorry. Yeah, sure. Go for it.
So I just want to add very quickly two things. So I think one thing that I noticed moving from Sandia to Meta, more academia to industry, is redoubling focus on getting stuff done. I feel like in academia, there is a lot of sort of like fluff around the core work. I mean, not that it's not all bad necessarily. There's a lot of talks. There's a lot of, large time-consuming conferences, there's proposal writing. The shift from that to industry, you want to get stuff done, cut through the noise, be productive, add value to your team. That's a total skill set shift that is definitely needed to go into industry and to be a doer, a finisher, not someone who talks a lot about work, but someone who gets stuff done. That's an important skill to sort of develop. Second is, I think, now in this new era, becoming very familiar with the full multimodal transformer technology stack, pre-training, post-training, how do you develop data pipelines for that? How do you build evaluations? That whole set of tools is more engineering than math oriented, but it's really important to be facile with all those concepts to slot into any kind of AI research, I think, in modern times. So those are the two things I would add.
No, these are great additions. Thanks for that. Okay, so let's talk a little bit about some career advice panelists may have, and maybe also their future outlook. And I thought I would want to start with Liz again, because she is probably the one who has most recently applied for academic jobs. And was a postdoc at Emory and then a faculty at Emory starting in 2022. Now she's moved to Taft. And not only has she applied successfully to tenure track jobs, but also to grants. So she's independently funded by the NSF and every YIP with the F4SR. And so in some sense, I wanted to get her thought about kind of what is the current, how was this experience like? What is the current academic job market in our field, and also sort of in what sense the data science part has been helpful or not helpful in this process.
Yeah, thanks, Lars. I would say the market for data scientists is actually not too bad in the academic world. A lot of schools have these new AI or data science initiatives, and I found that there were a lot of opportunities that I could position myself as a competitive applicant as long as I put a data science spin to it. So that was something that I was actually pretty optimistic about, given some of my friends who weren't positioning themselves as data scientists weren't getting the same opportunities. So I think I'm pretty optimistic that there's a lot of opportunities for computational mathematicians in academia. Was there, Lars, I don't know if I answered all the questions. Did I miss any questions?
So I think, you hit a few points that was going to hopefully come out. So there are special initiatives at the universities, special grant programs, that's for sure. But then sort of the other thing maybe to also add to that is, so since you've been advising students, say I'm a computational math PhD student who is starting this fall. Sort of, what is your advice to kind of build the skills that they want to build, and then also kind of keep the doors open for any career path?
Yeah, I think probably it's the same that I said earlier, though. It's just kind of build the math, the coding, kind of get up to date with current research by looking at what's being published at conferences or in journals. And I think what a lot of people talked about here, though, that maybe I want to mention is try not to get too siloed in one topic, and maybe talk to people in other departments or in other fields so you learn a little bit about how you might do some interdisciplinary work. That's something that I'm trying to learn to do better and better, because I think that's also pretty exciting in this time, is there's a lot of computational science, right? Computational biology, computational chemistry, what have you. Learn how to start thinking about how your skills can connect with other industries as well, maybe, and build that up. I don't know if that my 2 cents.
Yeah, so it seems like an interesting two-pronged approach. So get finish your dinner first, get your usual computational work or computational math coursework in, but then also at the same time explore other options, and maybe also would be good maybe to think about a way to kind of address what Marta has pointed out is maybe one of the weaknesses in the academic training, to be siloed in and not work on code or on other things with others. Are there any ideas maybe you can share with us that we could apply to get students work more collaboratively?
I mean, I think I don't know if this is more a student thing, but I'm wondering if it's maybe on the faculty side of, can we design courses or build teams that have forced this kind of interaction with students? So I try to design courses that students work in projects on group projects and start having these conversations, and they even have to start by writing a strategy to work together at the beginning of the project and things like that. Maybe that's something we should infuse more and more in our courses. Some concrete advice here.
Yeah, I like the idea of projects, and that would be my suggestion. When I was in my mathematical engineering program during my master's, we had a lot of projects that were very practical. And I think it was Operation Research or one of those exams. We had a very concrete project that was about scheduling how a city would pick up the trash. Very basic, but we were in groups of 3 people and we had to work together to code out that problem. And I thought it was very useful. Another thing is to push students to do internships. I always encourage students to do internships both in labs and industry first, because it gives you an idea of how it is and whether you like it or not. But it really gives you the idea of how it is to work in a team, and it prepares you for, you know, your future career.
Yeah, that's great. It almost seems like you would want students to have a bit of a portfolio project that you can look at when people apply.
Yeah, exactly.
The other thing before David comes in with asking one of our audience questions, I thought that would be important to bring up on the career advice was networking. In some sense, how should people here on the call approach networking? Because I feel like many of the careers or panelists have been building and everyone has been building have been steered by our networks. Does anyone have a good concrete advice of how to navigate this?
I love that. Networking was going to be my career advice. So you just took it from me, Lars. But I do think, by the way, I just want to double down briefly in saying, like, we've implemented the mega, like, front and center project-based, team-based learning, team science, and it is exponentially more valuable to the students when they're on the job market, but also in their own research. Like, I could talk forever about that, but Liz and Martha, you're absolutely right. And being on the other side of implementing a large scale version of this, we run like 50 projects a quarter with companies and other folks, and like it's a lot of work, but it is completely worth doing. But on the networking side, my advice is, look, almost every environment you find yourself in can actually be a networking opportunity. We just concluded like an REU here, very classic, have students come do research in data science. And at the very beginning, I asked people what they expect to get out of it. And they said, oh, research experience, like connection with my faculty member or deeper knowledge. And I said, great, that's what you should expect. What you may not expect and realize is maybe one of the most valuable things is the fact that there are 22 other students here and a whole bunch of other faculty and graduate students that you, over this period of time, will form a strong bond and network with that will help you through the rest of your career. You just don't know it yet. And that situation happens all the time. We create them in those environments like that. But I told them very concretely when I was 19, I was in an REU, a math REU. It certainly changed my career. I went from physics to math because of that REU. But later on, I'm still like 20, 30 years out now. God, I'm getting there. 20 years out, 20 and change out. I still connect with 10 of those 18 original people. Like, we still help each other get jobs, give each other advice, point out directions, collaborate on grants if they're still in academia. That's so long. And no one told me when I was 18, 19 in this summer RE that that was going to happen. Networking has been fundamental to my career changes, and I bet probably all of ours as well. Don't miss out on a networking opportunity and realize you're probably in one every time you're in an environment.
Well, Marta, did you want to add to that? Or see your
I,
mic?
I just wanted to add the importance of mentors. Wherever I went, I tried to find a reference point. And this is something I strongly encourage. Find that person that reflects your metric of success and learn from them. They're going to teach you how to write papers. They're going to teach you how to write proposals, or how to become a better manager, for example, in an industrial setting. One of the people here, Lior, was my mentor, and I learned so much from him. So and these people stay in your life, stay in your career, and you can always reach out to them. And I think that's very important.
Evan?
Yeah, I'll add one quick thing. So I always felt the best way to, network is to do really good work, give really good talks, and then seek out collaborators that complement your skill set in a way that ideally you'd like to grow. So at Sandia, I worked a lot with the uncertainty quantification folks there, Hachik Sargsyan, Habib Najm, and others. And I learned a tremendous amount from working with them. And my goal was to add some value from my background as a model reduction researcher, but also to learn a lot from them. And when you have that sort of yin and yang, that complementary skill set, that's when true collaborations and like real high value networking actually takes place, when you're doing productive work with people who complement your skill set that allow you both to do work better than you could do in isolation.
Yeah, that's also a great piece. Any other advice on, any more advice on networking, Lior?
Yeah, I may be able to say a few words. So I strongly agree with Marta's comment about mentorship, and also with David's point about looking at your peers, right? We often look up or down, and it's similar for those of you who have kids or one day will have kids. You may see them fighting among themselves, right? And at some point, they need to understand that probably the longest, most meaningful relationship that they will ever have in their life will be among siblings, right? They will have the longest period of time to know each other, more than their parents, unfortunately, or in most cases, right? More than their own kids, right? And once this sort of idea descends on you and you fully appreciate that, you understand that these are really the partners that you can run the longest mileage with. And if you develop the right network on the long run, that will definitely be meaningful and useful. So don't sort of ignore your peers. They are the ones that will be there for the longest part of your road. The other thing that I wanted to mention about networking is, so there's no substitute to face-to-face interaction, of course, or even web-based as we do now. You should obviously try to approach people in all means that you can. The other arena that we network is the social networks, right? And nowadays it becomes a little bit more and more significant, where each person becomes a little bit of a marketing agency of itself, right? You find that unless you popularize some of your work on a social network, others will do, and then you will be attenuated, right? So you may want to acquire some of the social networking, professional social networking. I'm not talking about putting a like to your friends' party photos or something. Maybe that's important as well, right? But LinkedIn and even X to some extent, these are some of the social networks where you can advertise your work. You may want to even later on in your career build relationship with reporters of journals, popular science journals, that will amplify the significance of your work. So think about networking as something that is very holistic, right? It has multiple dimensions, and you may want to put some effort and investment in many of them, and then you will, and it will get back to you, right? So it's not something that is necessarily a chore. You will actually start to enjoy some of that interaction at some point.
Yeah, that's a great perspective too, Lior, and I think it also speaks to finding new, maybe non-traditional ways to advertise your work, not just file a paper in the archive or in a journal and then move on, right? I think that could also be a good piece of advice there. I want to move, use the last few minutes that we have with our panelists to go a little bit through some of the Q&As. And I think one question we wanted to answer was Alisa's question. There's a lot, she's had like a lot of data science graduate programs have quickly been developed over the last few years. And how can someone tell which one are high quality and which one are sort of maybe thrown together as an afterthought, although I don't think that happens anywhere. But I think we have a few experts here that can maybe get us like a few things people can look at and if they decide between different options. David?
Happy to. I have a little bit of bias. I think the longer they're running the program, the more the kinks have been worked out. So all things being relatively equal, if a program's been around for 10 years versus 5 years, you're going to get more out of the 10-year program. Partly that's true through the alumni network here too, because again, back to networks, when you take and go through a degree program, particularly Masters in Data Science, which I've managed a number and led a few, is that the placements are very correlated to where the network is too. So the larger the alumni network base, the stronger the outcomes can be. That's not true if the education itself isn't really good. On the education side, my bias is to programs that, again, develop the concepts of data science from scratch and are not a laundry list of borrowed other graduate classes that cobble together and send them out as a data scientist. So to the extent you can see that there's unique direction and thought put in perspective into the program, the better. I also look for how they're integrated, to Martha's point, like over the summers with internships. Is it required? Is it encouraged? Is there good outcomes there? I also double down on any experiential learning opportunities. Finally, and again, back to my bias, I think any program that is not also teaching the students to think holistically about the work they're doing is going to put you into difficult positions in industry and also difficult positions in interviews. So yes, you have to pass a coding interview. You have to pass certain types of interviews, but if you cannot really think about the downstream impacts of your work or the ethical implications or the right ways to approach certain problems that come from non-pure mathematical or computer science related thinking, the more program has emphasis in that, I think it's a stronger program for the student outcome. But again, that's showing my bias too.
Yeah, that's probably a good opening, and maybe we can have some discussion on that based on other people's thoughts. Does anyone want to pick this up on the spot? If not, I would probably, based on some of the other questions that were posted, sort of lump them together and bring maybe another point. So, like, as someone who is looking at PhD programs, should they actually go for a data science PhD program or graduate program to be more general, or maybe do a computational math PhD or numerical analysis PhD? Like, does one have to, like, since most of us have a PhD not in data science, does it even matter, or are there sort of some other skills and ways in which that you can kind of benefit from other programs? Lior?
Yeah, so I would say I'm in favor of diversity. So I do think that this is one of the ways to bring more unique, creative, sometimes coincidental insights, right? But at the end of the day, either let's say a hybrid program or one that is dedicated to let's say more traditional mathematical sciences or computational sciences type of agenda. At the end of the day, this is something that one needs to relate to, right? So I would say the first thing is do you relate to the research itself? Do you find it interesting? Do you find it exciting? Are you curious about what you do? If everything is equal, again, my personal inclination would be diversity, right? It's good to command more than one topic as your core. It may provide you more hooks to connect with other researchers to do projects that are going outside the mainstream. But at the end of the day, really, it's really about what you feel passionate about and relate to.
I think that's a good take, because otherwise it will be very hard to sustain this for 5 years or longer. Marta?
Yeah, I wanted to add maybe a distinction that one can make between data analysis and data engineering, and that's up to the person, I think. But on one side, you have something more focused on the actual analysis of the data, building models out of the data, but we cannot forget about the data collection, data pipelines, DevOps operations, and I'm a big fan of building foundations, which then means, having physics and mathematical foundations, because you have to do something with those data and understand those data. But I think it would be great in computational math programs to also have some courses on data engineering, because at some point you may be in the situation in which you don't have data and you have to go and collect your data and interact with machines and learn APIs and things like that. And that's data engineering, and it's something that people that do computational math do not necessarily have.
Yeah, great point. Kevin, you have your hands up.
Sure, yeah. The one thing I would just quickly add to all that was just said is I think more important than the degree or your research topic, it's to really be an omnivorous learner, to be sort of going after everything that is relevant and to be adaptable to see changes in technology. Right now, I mean, my PhD was in aerospace engineering, so like we're far from that at this point. So the key trait is like, number one, again, be an omnivorous learner. Number two, have a growth mindset. If you have a really strong background in computational math, you can pretty much learn anything in AI and machine learning if you put your mind to it. So that's by far the most important trait, as opposed to the specific department you got your degree in or the program that you went through.
Yeah, that's great. And then maybe as a final question that was asked early on, and I love it, is it goes specific to Marta and Kevin. So you talked about this transition from national labs to industry and so on. Are these changes reversible? So do you know that there are people actually going the other direction too, from industry to national lab, for example?
Maybe I can start. I always wanted to stay connected to academia, and for this reason, I have this adjunct professorship with Stanford. I have students. Right now, I have 2 PhD students. That keeps you very connected to academia, and you also have the opportunity to teach. So I do think it's reversible as long as you want it to be and you work towards that. So I don't think it comes for free, but it can certainly happen.
Yeah, I would
Right.
add to that. Yeah, it's very common to go back and forth. I had a really good friend who went from like Dropbox to Sandia Labs, and he sorry. And he had no problem making the transition. He really was looking for more of a like balanced pace of life, deeper research, as contrasted with the high pace of life in tech. So it's easy to go back and forth, but it is a different set of skills you're going to be developing in a different kind of work environment.
Okay, great. I think we're at time. I feel this discussion has been really interesting. I'm really thankful for all the panelists. I think we should could keep going for another hour. Yeah, I'm really happy for everyone who attended. I hope we got most of the questions answered. And yeah, thanks again for this nice webinar. There will be one more coming in about 3 weeks' time. We'll reach out through the listservs. Topic will be probably very different. We're thinking about something tutorial-like. If you have any thoughts about the series, let us know. And also, once the recording is out, feel free to share it with your friends. Anyway, thanks. Have a great day, everyone. And thanks for joining.
Thank you very much. Bye-bye.